I have made that into a table presentation like this. So the cost elements are written, plants are written, warehouse is written, corresponding capacity and demand is also written. So as you know that the first step in all this is to check whether demand equals supply or not. So is those who have solved, please let me know whether the demand is equal to supply.
Yes, sir.
Yes, sir.
Yeah. So demand equals supply. So both, if you sum it up, you will get it as 130. So demand equals supply. Okay, right. Now, if we are applying the northwest corner rule, you will get the solutions like this. So 40 here, you will get 15 here, then another 35 here, and 10 here, and 30 here as your assignment. Was it correct?
Yes, sir.
Yes, sir.
Yeah. Okay. So I'll continue with this problem for finding or to checking the optimality solution. Okay. So since you know that since we are applying northwest corner rule, the problem is not going to be optimum. So I will have the scope to go for some iterations and to see to that when and how I am going to get an optimum solution in this regard. Okay, so this the same way I'll continue for the next part. So next stage. So stage 2, checking for optimality. And there are two methods you have seen in the PowerPoint. The method one is known as stepping stone method. And the second method is called as modified distribution method or MODI method. It is also known as UV decomposition method. Okay, in some book it is given as modified distribution method. In some book, especially the foreign author books, they will write you as it as UV decomposition model or method. Okay. Now, whatever the case is that the first case I am not going into detail. We will see only the second method. Okay, we will see only the second method. Whether you apply the stepping stone method or MODI method, the first step, okay, the step 1 will be you need to check. Okay, you need to check the solution is degenerate or not. Okay, the solution is degenerate or not. Okay, how will you check this? The solution is degenerate or not. So you have to check. Okay, so that is you have to check number of allocations. Number of allocations should be equal to m plus n minus 1. Okay, the number of allocations should be equal to m plus n minus 1. Here how many rows are there? Where m is the number of rows. Okay, m is number of rows and n is number of columns. Okay, M is number of rows and N is number of columns. So how many allocations do we have here? How
Five.
many? We have five allocations. So 5 is equal to what is the value of M?
3.
3. 3 and rows N
3.
is 3. So 3 plus 3 minus 1, 6. So we can say that, okay, so 5 equals 5. So this is the solution. The initial solution is non-degenerate. Am I right?
Yes, sir.
So we can say that since number of allocations is satisfying this condition, we can say that the initial solution is non-degenerate. Okay. We can say that the initial solution is non-degenerate. Okay, if degeneracy occurs, what will happen? I will explain you when I solve a degenerate problem to you. From this problem, you will not be able to clearly understand, okay, what is the effect of exactly this degeneracy is. Okay, when I solve you a degeneracy problem, you will able to understand it. Okay, now the next thing, in this table, you can see there are some kind of allocated cells are there and some non-allocated cells you can see. See, for example, if we see this particular cell, okay, this particular cell has allocation, this particular cell has allocation, this has allocation, this particular cell, and this is also having allocation. And there are cells where there is no allocations are or not there. Okay, so okay, so the cells which you have allocations, okay, the cells which you have allocations, they are called as stone square. Okay, they are called as stone square. The cells which does not have any allocation, they are called as water square. Okay, so now if we see, as I marked here, AP, BP, BQ, CQ, CR, they are, okay, they are basically the stone square. Rest all the unoccupied one, they are called as water square. Okay, so the occupied cell, so you can see over here, the occupied cell, so that is called the stone square. Okay, so this is called stone square, and the unoccupied cell, okay, the unoccupied cell, they are called water square. Okay, they are called as water square. Okay, was up to this is clear?
Yes, sir.
Yeah, okay, right. Now, if we take the, so the step one we have seen, step one we have seen. Now, if we are going to this Modi method or the UV decomposition method, so this row wise, okay, or we can see the first row that will be marked as U1. Okay, so that will be marked as U1. Okay, U1, this will be U2, this will be U3. Similarly, this the first column, that will be V1, this will be V2, and this will be V3. As per this problem, you have U1, U2, U3, and as column wise you will have V1, V2, V3. Okay. Now, how do we find? How did we find whether a better solution exists or not in the linear programming problems? How was that done? How was that done?
Sir, until that L becomes less than 0, greater than 0.
What becomes less than 0?
Uh, the variable.
We have calculated Zj minus Cj. Zj
Of
minus Cj, we have discussed it as the net cost change. So net cost change, if it is a negative value comes, we say that a better solution exists over the present solution. Am I right?
yes.
Yeah. So the same thing you have to apply here also. You have to calculate the net cost change. But the equations will be different in this case. It will not be as same as that of your linear programming. Here that is going to change. So how to calculate it? How to calculate the net cost change? Okay. So net cost change. Okay. It is. I'll write the equation here. Net cost change equals Ci to j. Ci to j is the cost information for that particular matrix minus uh, 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 minus ui plus kj. Now, for which cells do we need to calculate the net cost change? For which cells do we need to calculate the net cost change?
Allocated cells.
Allocated cells or the unallocated cells?
No, I'm not unallocated, so that only we need to consider.
Eh?
I'm not unallocated, sir.
Yeah, so we have to calculate the net cost change for the unallocated cells. That is basically the water square. Okay, so this you have to calculate for the water square. Okay, so I'll write here water square. You can calculate the net cost change. Okay. Okay, right. So now for calculating the net cost change, so we have water squares. Okay, we have water squares here as water squares as AQ, AR, we have BR and CP. So we have AQ, we have AR, we have BR and we have CP. Okay, so we have the four. Now, what information do we have? We have only the information of Cij. So AQ, you can see to that if I say the AQ value, okay, if I say the value AQ, so AQ will be equal to Cij value is 9, 9 minus, okay, it is 9 minus inside the bracket, it will be U1 plus V2. But the values of U1 and V2 is not known to us. Okay, so AQ, if we are writing the equation for AQ, Cij is C A to Q, so it is 9 minus, okay, U1 plus V2. Okay, so net cost change AQ equals C AQ minus inside the bracket you will have U1 plus V2. Okay. Now, how do we calculate this UV value? Now, how do we calculate this UV value? So this UV value you have to calculate initially from the stone square. Okay. Similarly, everywhere I can write it like this. So AR will be CAR minus inside the bracket you will have U1 plus V3, and here BR will be C of BR minus B position will be U, so it will be U2 plus V3, and same way CP will be, so C of CP minus U3 plus V1. Okay, so these informations you have to calculate from the stone square. Okay, so stone square equation, I can same way I can form the equation and I can get the values of U and V. Value of U and V. So what are the stone squares here? What are the stone squares here? AP, you will have BP, you will have BQ, you will have CQ, and you will have CR. Okay, so stone squares are AP, you have BP, you have BQ, you have CQ, and you have CR. Okay, now what is the equation of U and V for AP? What is the equation? For AP. So AP it will be U1 plus V1 equals Cij equals 11. Okay, U1 plus V1 equals 11. Same way here U2 BP equals U2 plus V1 equals 12. Here BQ it will be U2 plus V2 equals 14. Okay, so that's the way I can write the equation. So AP equals U1 plus V1 equals 11. Okay, next one. BP equals U2 plus V1 equals 12. The next one, U2 plus V2 equals 14. Next one, U3 plus V2 equals 8. And CRS U3 plus V3 equals 10. And my first assumption will be U1 will be always equals to 0. Okay, so my first assumption will be U1 will be equal to 0. Okay, now if I put U1 equals 0, value of V1 will be
11.
V1 will be 11. Substituting the value of V1 over here in the second equation, you will get U2. What is it? U2 is
1.
1. Substituting the value of U2 in the next equation, you can get V2.
13.
Okay. Substituting V2 here, you will get U3.
-5.
Okay. Substituting U3 in the next equation, you will get V3.
6.
Value is 6. Okay. Now you have known all U and V. Now calculate the net cost change. So CAQ value is 9. So 9 minus U1 as 0. V2 we have calculated as 13. And CAR value is 6. So 6 minus 0 plus 15. Next one, 11 minus 1.
V3 is 6.
V3 is, sorry.
6.
Sorry. So V3 is 6. Okay. So 11 minus U2 is 1. So 1 plus V3 is 6. And next one, C of CP is 10. So 10 minus inside the bracket, you will have U3 is -5. So -5 plus V1 is 11. -5 plus 11. Okay, get me the values. Get me the value.
-4, 0, 4.
-4. So I'll get it as -4.
0,
0.
4.
How much? 4.
4.
4. Okay. So I made a mistake here. So U3 plus V3 is basically, it's not 1, it is basically 10. U3 plus V3 equals 10. Sorry, that's a mistake was made here. So instead of 6, that value will becomes, this becomes 15. So here, so this is 15, this is also 15. So get me the new value.
minus 9.
Yeah, so this will becomes minus 9 and this will becomes minus 5. Am I right? Yeah, so net cost change, what is the status is? So net cost change, negative value indicates a better solution will exist. Okay, a better solution will exist. Okay, so we have -4, -9 and -5. So which one will be select? Which one we will select?
-5.
No, the one with largest negative coefficient. Okay.
Oh, minus, sir. Okay.
Yeah. The one with largest negative coefficient. Okay. So we can say that -9 is the case. So we have to select the cell AR. Okay. So AR we need to solve first. Okay. We need to solve for the AR first. Now how to solve? So we had this same table, no modification. So I just add the initial solution here. So that was 40 here. This is 15 here, 35 here, 10 here, and 30 here. Now, which one we have selected now? Which one we have selected here? We had selected A, R. Am I right?
Yes, sir.
Yeah, so we have selected A, R. Okay, now what you have to do is that you have to form a loop to AR. Okay, you have to form a loop to AR in such a way that only horizontal and vertical lines you are supposed to draw. Okay, only horizontal and vertical lines you are supposed to draw, and the end point of these horizontal or vertical lines should be only on stone square. Okay, so next step. Okay, so step 3. Draw horizontal or vertical lines. Okay, draw horizontal or vertical lines. Okay, and end will be on stone square and form a closed loop. Okay, so we have so tell me how will I form the loop? So how will I form the loop? Starting from AR. Now if I draw a horizontal line, it will go to, okay, it will go to AP. Am I right?
AR
A.
will go to AR, then
From AR, I have
you need
drawn the line. Okay. From AR, I am drawing the line to AP. Okay. Next vertical line AB. Next vertical line, sorry, next horizontal line BQ. Another vertical, another horizontal, and then another vertical. Now does a closed loop is formed? Does a closed loop is formed? Yes. Am I right? Is it? Are you clear? This has
yes,
to
sir.
be drawn. This has to be drawn in the shortest form. Need not to cover all the stone squares. For example, if you got BR as your largest negative, then your loop will be something like this. You have to ignore these two. These two you have to ignore. You have to form in the closed loop in such a way that the endpoint will be in stone square. Okay, suppose it is BR, it will be forming a loop like this. You will form a loop like this. And suppose you have a 30 over here. This 30 is here. Then you will form a loop like this. And at that case, 35 is also ignored. Clear? Is that clear? Loop you are forming in the lowest possible condition. Okay, now when once the loop is formed, you have to add plus and minus signs. Okay, plus and minus signs, plus and minus alternative signs, starting from the selected water square as positive. Okay, so this is what we have taken. So this is plus, this cell becomes minus, this cell becomes positive, this cell will becomes minus, this cell will becomes positive, this cell will become minus. Either you rotate in a clockwise or you go in anti-clockwise, whatever the direction is, the sign, the method of sign will remains the same. Okay, so step number 4. Step 4. Okay, mark alternate plus and minus sign starting from selected water square. Now step number 5. Okay.
Sir,
Step
what's
number
the sign for AQ?
A.
AQ.
AQ no sign. Wherever my horizontal or vertical line ending in the stone square, there only I need to put the sign. The indication of the sign is that these are the occupied cells. From these occupied cells only I can able to move some data to AR. You got it? From the occupied cells only I can able to move the data or the quantity to the unoccupied cell. Okay, and whatever is moving to AR now, I need to subtract that from AP and similarly from CR to maintain my table consistent. That is, for example, if I move 40 to AR, okay, if I move 40 to AR, then the 40 has to be subtracted from here. Same 40 has to be subtracted from here. Then only my net distribution will become tally. Okay. Now you can see if I move 40 to here, you can see I cannot make this to 0. Then 40 I cannot move to here. You see here it is only 30. But here 40 is there. Okay. Do you got that?
Yes, sir. But the 30
So
is already taken from CR, no, sir?
30.
The 30 value is taken from CR.
No, wherever from what, if I take 30 from here, if I take 30 from here, this will become 0. This has to become 10. Then only the 40 will tally here. Then this 15 has to modify. 15 becomes 30 plus 55. 30
Okay, sir.
plus 15, 45. Okay, then here that to accommodate that change, you need to modify here. Then to accommodate that change, you need to modify here. So total change you have to do. So now what quantity you will select and what quantity you are going to transfer. Okay, now see negative sign. Okay, see negative sign where all which all cells minus sign is coming.
AP.
Negative signs. AP, what's the value?
AP 11, no.
No, tell me the quantity. It is minus 40. Then
Then minus 35 for BQ.
BQ is minus 35, and then
CR minus 30.
CR will be minus 30. Okay. Now select the lowest negative. Okay. Select lowest negative. Okay. Add wherever plus sign. Okay. Subtract wherever negative sign. Okay, add wherever positive sign, subtract wherever negative sign. Okay, now what will be the new matrix becomes? What will be the new matrix becomes? So this will become 40 minus 30. How much will be the new value in AP?
10.
AP will be the new value will be 10. Okay. Then what will be the value on AQ? Any value change will come on AQ?
No, sir.
No. In AR?
Yes, sir. Plus 30.
Yeah, AR becomes plus 30. Okay. Now BP?
BP. 45.
BP becomes 45. Then BQ?
I think it becomes 5.
BQ becomes 5. CQ?
40.
CQ becomes 40. Okay. And CR? CR 0. Okay. So CR 0. Now CR becomes a water square. Okay. Now CR becomes a water square and AR becomes a stone square.
Okay.
Okay.
Sir, we should continue this whole thing until we'll get no negative value.
Yes. Until all net cost change becomes positive, you need to continue this. Okay. Is the methodology clear? Okay. So now new stone square. So this will be U1, this will be U2, this will be U3, this will be V1, this will be V2, this will be V3. So now new stone square will be AP. Okay, so U1 plus V1 equals 11. Then it will be AR. Okay, AR is U1 plus V3 equals 6. Then it will be BP. So BP it will be U2 plus V1 equals 12. You will have BQ. BQ equals U2 plus V2 equals 14. Then you will have CQ U3 plus V2 equals 8. Okay, like the first condition. Okay, U1 equals 0, you will get V1. V1 is how much?
11, sir.
V1 is 11. Okay. And V3? V3 equals
6.
6.
Right.
Then U2 equals
1, I think.
U2 equals 1. Then U2 you can substitute. You can get V2.
13.
V2 is 13. And V2 you know. So get me U3.
13 plus 6.
Minus 5.
Minus 5.
Minus 5. Now you calculate the net cost change. Okay. Calculate the net cost change for cells AQ, cells BR, cell CP, and cell CR. So AQ will be 9 minus Ci2j minus U1 plus V2. U1 plus V2. BR will be 11 minus U2 plus V3. CP will be 10 minus U3 plus V1 and CR will be 10 minus U3 plus V3. Get me the value.
AQ is minus 4.
AQ is minus 4. Okay. BR.
4.
Okay. CP.
4.
Okay. CR.
9.
Okay. Any negative value is there?
AQ.
AQ. Okay. So AQ is this cell. What is the next step? What is the next step? We have to
Draw
form
loop
the closed loop. How do we form the loop?
from AQ.
AQ to which cell?
AQ to AP.
Okay. Then
Then AQ to BQ.
A,
AQ to BQ.
AQ to BQ. Okay. Then
Then B to BP.
okay. And then
Then
we can
BP.
connect.
Yes.
Yeah, BP to AP. Right. Now, what is the next step? What is the next step?
Pass
Plus and minus. So what will we start with plus?
That box AQ positive, AQ positive.
AQ is positive, AP
B,
is negative, BP is positive, and BQ is negative. Actually, I forgot one step in between. You have to calculate the transportation cost in each and every iteration. Okay, that I forgot to tell you. Okay, since it is not optimum, I didn't tell you to calculate it, but when you calculate it, you will know whether any cost change is happening or not actually or not. Okay, now what value will change?
minus 10 will minus 5 will change.
Minus 5 we will change. Okay, right. Okay, so all so tell me the new values. So AP will becomes
5, 5 sir, 5.
AP will becomes 5.
BP 50,
BP 50. Okay.
BQ 0,
BQ0. Okay. Then
AQ 5, AQ 5.
AQ5. This 30.
It won't change. It is not in
It
the loop.
won't change. It will remains as it is. Okay. It remains as it is. So you will have the values like 5 here, 5 here, 30 here, 50 here, and 40 here. The new assignment.
Sir, this will be last iteration. No, so you can calculate directly. Right?
Pardon me?
This will be the last iteration rate. Like we
Need
can.
not to need not to be, sometimes may vary also. We can't guarantee it. Okay, so you can calculate the transportation cost. What will be the transportation cost? Eleven into 5 plus 9 into 5 plus 30 into 6 plus 12 into 50 plus 8 into 40.
1200.
Okay, 1200. Again, calculate the 4 stone square. You can calculate, and you can calculate for the net cost change for water square. APAQ AR, it is BP, and it is CQ. So AP, from AP you will get U1 plus V1 equals 11, U1 plus V2 equals 9, then U1 plus V3 equals 6, U2 plus V1 equals U2 plus V1 equals 12, equals equals 12, and then u3 plus v2 equals 8. So u1 equals 0, v1 equals 11, then v2 equals 9, then v3 equals 6, then u2 equals 1, and u3 equals -1. Okay, the net cost change we will have for BQ, we will have for BQ, BR, CP and CR. So BQ it is 14 minus U2 plus V2. BR it is 11 minus U2 plus V3. CP is 10 minus U3 plus V1. CR it is 10 minus U3 plus V3. So net cost change by substituting the values. BQ is 4, then BR is 5, CP is 0, and CR is 5. So all net cost change are positive. So net cost change is positive. End of iterations. End of iteration. Optimum transportation cost rupees 1200, and this will become optimum allocation.